Okay, so we're we're about 10 minutes from the start of the light frames. The darks and bias frames have been completed, and tracking C is still off. And what happens is when it gets to exactly, okay, so now we're 10 minutes from start time. Now you can see the telescope will start up. It's now going to slew to the target. What happens, it'll slew to the fireworks galaxy, then it will do a plate solve, and if it needs to correct that position, it will. And then what will happen is it's going to actually slew to a focus star at 60-degree altitude or higher, and then once it's completed with the focusing, it's going to go back to the target and start the actual imaging. So let's go to the autopilot and see. Okay, so it says the scope is slewing, telescope is unparked, and let's follow what it's doing there. So so the mount settles for 5 seconds just to stabilize. The initial focusing now is with the luminance filter. You can see it says focusing with luminance filter. It's getting the focus stars. It moves to focus star number 1 and slews the scope there. So let's go now to the focuser. And I like to watch this up in here. Kind of gives me an idea of how good actually the seeing is, because focal length of 2800, generally the half flux diameter is going to fall somewhere between 5 and maybe 8 at the very worst. If the seeing is good, it's going to be in the 5s. And you can see here, this is the star that's been selected. It's in the center. And we're starting at 6.73. That's not too far away, but we'll see where it winds up. So again, it's focusing with the luminance filter, where the automation program will select the star. You define it to be within a certain magnitude range, and it uses the stellar databases in the sky to select those stars. So this looks like it's kind of winding down here. We may be in the low 6s. Let's see. That being the case, then we're probably looking at maybe average seeing. And yes, so we're at 6.5. If we go to the seeing window, you see here, yeah, we're between 2 and 2.5. So it's pretty average. It's not really as great as you would like it to be, but it's not terrible. So now the focusing is completed, and what you see here, I just want to point this out. Once the telescope is focused with the luminance, it's going to make the correction to arrive at the focus position for the HA filter. And so you see the rotator is moved to the target position, and I'm just waiting here. I think it does that just before it starts the light frame. So now it's plate solving, and this mount is quite accurate because it does have the on-axis encoders, and you can see the error is only an arc minute in RA and DEC, so that's quite good. The upper limit is about 15, but typically it's within a couple of minutes at most. So now it's corrected the position. Here you see, this is what I was looking at. The focuser is moved by 330 steps, minus 330, to this position. So it automatically does that before taking the exposure with the actual filter you're going to use for the series. Let's go back here and look at this here. And what we're seeing is here's the guide star here. And what I did notice when I was demonstrating this earlier is that there, unfortunately, is a very tiny star that's next to this, and that's what was confusing me. It was reading 12th magnitude. So we'll have to see if this becomes a problem. It may not be. Here's the star now identified, which is the brighter star, obviously. And this will stabilize over the course of the next 2 minutes, hopefully. Here's your guide error, and you'd like to see that generally less than a pixel for the most part. Now, I am not binning the guider here. So the reason is that I found that it was just so sensitive when I did that the guide exposures had to be so short, and it just seemed to work better if I left it at 1x1 binning. So the errors, while they do seem to be at times more than what you would like, I think that they're overestimated because of the fact that the guider is not binned. But for the most part, during the exposure, the errors are less than about a pixel. Here's the galaxy here. You can see this on the scout view, the plate saw view. And we're shooting hydrogen alpha. I really don't know what to expect. What the idea is, we're trying to bring out the H2 regions in the galaxy, and I don't even know if there's going to be much there or not. But since the moon was out, I thought it was a good idea to give this a try. So you can see that the exposure has started, and the guide star is still in good position here. The errors are so far not too bad. Sometimes it will actually take a couple of subframes before it kind of settles down, and so that's something that we watch out for during the course of the night. And so what's going to happen is it's going to take these 15-minute images and go through that during the course of the evening, and it automatically stores the files to a folder that we will be looking at in the morning and checking the quality of the subframes in terms of the guiding and tracking, etc. And hopefully we can keep more than we throw away. And that's pretty much it. In the morning, it will take the dawn flats. We might check in once before that happens, but the telescope will park after these light frames are completed, and then we'll park again after the flat frames are done. So we will check in the morning.